today we're in section 4.2, greatest common factor. All right, the definition of the greatest common factor is it's the largest common factor between two or more numbers. It has to be in all of the numbers in order for it to count, but that is what we call the GCF. All right, so in example 1, we're listing factors to find the GCF. You do not have to write this down, but I do want to show you just to make sure it gets included in the video and also just for reference purposes. However, you will not be asked to find the GCF this way. I think that it's a little more tedious, and I just prefer prime factorization. So that's the way we will do it. But I am going to show you. So you have these two numbers, 60 and 96. Just look up here. Watch along with what I'm doing. 60 and 96. The first thing I need to do is I need to actually list out all of my factors. 1 times 60, 2 times 30, 3 times 20. You see what I'm doing here? All these numbers can be multiplied together to equal 60. Then I do the same thing for 96. And I list out my factors. Then when I list out my factors, all right, I'm going to look at all these factors, and I'm going to ask myself, what is the largest factor between both of them? And what do you see? What number is the largest number that both of them share? Do you agree? It is 12. 12 is the largest number, the largest factor that both of them share. So my GCF is 12. All right, any questions on that? If you don't understand that, honestly, it's not really that important because you can use prime factorization, and that's the method that I prefer. All right, so now I want to use prime factorization to find the GCF of 84 and 216. Yesterday you learned 2 ways to do the prime factorization. Does anybody remember the 2 ways that we learned yesterday to do prime factorization? Deja, what's one? Upside down division. What's the other one? Cabria? Factor tree. Very good. Now, it's up to you which one you choose, but from here on out, I'm mostly going to use upside down division because I just think that it's easier. All right, so upside down division. What's my only rule for upside down division? I have to divide by what kind of a number? A prime number. So can I divide 84 by 12? Well, but 12 goes into 84, but it's a composite number. Can I divide 84 by 7? Yes, because 7 is prime. Now, in my opinion, it's easiest to start with the number 2 if it's an even number. So I would start with 2, and then I'd keep dividing. And then you know you're done when that bottom number is also a prime number. Go ahead and do your prime factorization. And then on the bottom of the page, I want you to list out your prime factors. All right, so go ahead and list out your prime factors on the bottom of the page. All right, so now I did the prime factorization of both numbers, and I listed out my factors. Okay? If you don't have this, go ahead and copy this down right now. All right, go ahead and copy this down if you don't have this. Does anybody see a common factor that both numbers share? Deja? 3. Very good. What's another common factor? 2. And do I have another group of 2s? Very good. So 2 groups of 2s and a 3. So now over in your GCF, I want you to write each group one time and multiply those numbers by each other. And what do you get? So GCF is 12. Okay, so you circle the common factors, prime factorization, circle common factors, and then GCF is 12. All right, questions? Anything? So now, what if you have 3 numbers? I want you to do the prime factorization of all 3 numbers and list the prime factors, just like we just did in the last example. Okay, so we do the prime factorization of all 3 numbers. And then we list out the prime factors. All right, why do I have multiplication signs between my factors? Does anybody remember what I said yesterday? Why do I have a multiplication sign between my factors? Remember my example of the puzzle? Anybody remember what I said about the puzzle? What did I say about the puzzle yesterday? All right, very good. So I've got a puzzle, and I can break it into its pieces, right? Does that make it not a puzzle anymore? No, it's still a puzzle. It's just in its pieces. And can I put it back together? Yeah. Absolutely, I can. Okay, so that's what I'm doing with these numbers. I'm taking a composite number, a very big one, and I'm breaking it down into its prime factors. Does that make sense? But if I multiply all of these numbers together, it should still equal 110. What is 2 times 5? 10. What's 10 times 11? 110. So do you see that? All I'm doing is writing that number with only prime factors. Do you see that? Now, I need to circle my common factors. What's a common factor in all three numbers? It has to be in all of them. What's a common factor? 11 and 2. So GCF is 2 times 11. Wait, hold on. What about these two 2's? But it's not in the top one, so it can't count as a group. GCF is 2 times 11, which is 22. All right, so in order for it to count as a group, it has to be in all three numbers. All right, so now one more set of numbers. I'm going to do the prime factorization of 65 and 112. Give you just a minute to do that. These aren't very long. Okay, I want you to do the prime factorization of 65 and 12. And then list out the prime factors again. All right, so now I'm going to do the prime factorization and list my prime factors. Is everybody to this point yet? Yes. Okay, but what do you see about the factors? What do you notice? There's nothing in common. So when there's nothing in common, except what number? What number is always a factor of a number? 1. So if there are no other common factors except the number 1, I call these two numbers relatively prime. They have no other factor in common except the number 1, so these numbers are relatively prime. You have a section like this on your homework tonight where you're doing the prime factorization, matching up the factors and telling whether the numbers are relatively prime. So if they are, your GCF is 1. If they're not, then your GCF will be some other number. All right, and if you understand that, that's everything you need to know for section 4.2.